Okay, here's the block that I did all the cutaways on the other day. Put everything back together so that we can actually pull this thing apart and dissect it so you can get a view of how certain sections look as they're coming apart. So the first one's going to be the front side. So we'll peel this out and kind of give you guys a look at how that is set up. So I know people were worried about the front cylinder number one, how it was a little thinner on this side, but you have to understand that this is a non-thrust side, so the thrust side's always going to be thicker. When you bore these blocks out or you go oversized pistons, you have to understand that even though if it's a 20 or 40 over, it's calculated out to be 20 thousandths per side to equal a 1 mil over, or 10 thousandths per side to equal a 20 over. So pulling that amount of material off this is not going to hurt anything. But yeah, it's weird how they doubled it up on this one. So there's the pull-out cutaway of that, and it just goes to show you can see how that system is set up. And so here's the man-of-war galley right here, and there's the coolant galley and the coolant jackets that go around each cylinder. Now we'll move this section out. I'll put this, tell you what, I'll put this back, the front. And we'll pull this section out, and this gives you a good look at how the system is ran. Yes, the coolant galley and these things are pretty bad in the middle. Towards the ends they're actually pretty open, and I know a lot of the theory where everyone's saying that, oh, you know, number cylinder 6, which that's the coolant galley here going around the cylinder. Man, I'm terrible at pointing this stuff out of the camera. This is cylinder 6. That's the coolant galley going all the way around it. So it's not that the coolant galley has any problems, it's just here in the middle. So technically, if you had a big enough bit that you could go in here and come this way all the way through and stop midway and then come back the other way in the coolant galley with a big bit and come through, not a die grinder, but literally if you set this thing up in the mill, it'd work out to your advantage if you did that. However, you also have to look at too that this system is pressurized with coolant, just like a boosted application would be for air. Water is going to get where it needs to be, but the biggest thing is that if you don't have adequate piston to wall clearance, it's going to generate a lot of heat, which is going to end up transferring into the coolant, and that is where this cylinder will start to get hot. Now I know that the last two cylinders end up getting coolant, but if you have proper clearances and adequate setups, none of this stuff's going to heat up. So it's important that you look at running these things a little more on the loose side, just because it helps with not only thermal transfer going into the coolant and the engine oil, but it also prevents friction heat being built up into the piston and the cylinder wall, just from the piston going up and down the bore. So that's another thing to consider when you're shopping around to look who's going to do what as far as machining your engine. Make sure you talk to people and figure out what's the best oil clearance you need to run between the piston and the wall, because it is extremely important. A lot of guys out there, and I know who they are, they like to run the minimum 2.5 to 3 thousandths clearance on a Wiseco piston or a CP, and that is just absolutely about the worst thing you can do. And that's the reason why you get these cylinders that get hot around these jackets here, because you've got too much friction built up and you get a lot of heat generated. Moving on, look at the main system. Look how sturdy, and kneel down here, look how sturdy this is. That is an inch. I'm going to get the dial caliper and I'll take some pictures of it, but your cross section here is extremely thick, and then it widens out here. It spreads the load all the way through, and all this is support for the main, all of it. We're not talking about the girdle, we're just talking about the main web. We know that the girdle is the weak point. It is the weak point. I don't care what anyone has to say. It is the weak point. This is not the weak point. It never has been. You guys are talking about looking at this. You think that this pinch area right here is the weak point, but you have to understand this is the gusset. Look at the material going into the pan rail, the gusset to the cylinder wall, and then this, from this point all the way up and around to the other side, is one entire gusset that ties into the bottom of the block. Guys, you're not going to destroy this block. The only time these blocks have been destroyed is because the girdle let go and the crankshaft changed all the geometry on the rotating assembly and shit started messing up. I promise you, billet main cap is the best solution out there. That's the most affordable, most economical. It will get you to where you need to be to the next step to make over 1,000 horsepower. I promise you it will be. So moving forward, there's cylinder 6. You can see the cutaway there. Okay, here's the other half on the back side, cylinder 6. And now we're going to take this part off. And now you've got this big oil main galley right down the middle. Number 4 main, 3, 2, and then the 1. Okay? And that's the breakdown of the VG30. It's pretty simple. It's pretty basic. Yeah, I agree. The coolant galley is much to be desired. It is what it is. It's 80s, 90s technology on casting. Things have gotten better throughout the years. But this is what you got to work with. This is what you got to do. So I just wanted to confirm and let everybody know the main web structure on the VG30 is not weak. I do not care what anyone has to say. You can argue with me until you're blue in the face. Really don't care. Really do not care. Just don't. Even though it's still a 2-bolt main, all the other systems out there are still a 2-bolt main, so they're not doing anything more than what my billet main caps are doing. But look at the gusseting that I've explained here. All this is structure. All of it. You're not going to break that if the system is set up correctly. Lascano Racing runs a billet main cap kit. Yes, the 2 middle caps have 2 outside splayed bolts, but they're only an M8 bolt and it has no load to the outside. It was only there to make sure the cap didn't twist, but he's making over 1,700 horsepower to the wheels, which is over 2,000 at the crank. So for 95% of the individuals out here that are wanting to make 1,000, 1,200 horsepower, the billet main cap kit with the girdle that I have does the job and more, and will support it all the way up to 1,500 to 1,600 horsepower without issue. So there it is, guys. It's the whole kit ready to go. Any questions, comment below. Thanks for watching, and keep tuning in, man. I got a whole bunch more projects coming in the door. Thanks.